Hello, this is Mr. Collier, and today we're looking at capacity and density problems. Okay, so a new perfume is 36 millimeters in diameter. If the bottle is full, calculate its capacity in milliliters. So first of all, let's look at the question. We have 36 millimeters here, so the radius is going to be 18 millimeters. We want our answer in milliliters. Remember, 1 milliliter equals 1 cubic centimeter. So before I do my calculations, I'm going to change that one to centimeters to make our calculations a bit easier. Okay, now I need the capacity, which is the volume of this. So I'm going to check out the formula for the volume of a sphere. It's 4/3 pi r cubed. So volume is going to be 4/3 pi r cubed, which equals 4/3 times pi times 1.8 cubed. Okay, so I'm going to get my calculator and do 4/3 pi r cubed. I need to type in 4 divided by 3, or you can make a fraction, times pi times 1.8 power of 3 gives me 24.4. So this is 24.4, and because we use centimeters in our question, we know it's going to be cubic centimeters in the answer, which equals 24.4 milliliters. Okay, the next example, 17.3 millimeters of rain falls on a flat rectangular shed roof. Okay, so what that means, basically, if 7.3 millimeters of rain falls, so if it falls into a rectangular, let's say, container, even though it's not very much of a rectangle, let's say it falls into this rectangular container, then what this means is that the height of the water will go up 17.3 millimeters. Okay? Or any container, the height of the water will go up to 17.3 milliliters. So we can think of it this way and find the volume of this rectangular prism here. Okay, and the height here is going to be 17.3 millimeters. Alright, so the rain falls in there and then it gets poured or drained into a cylinder. Okay, and well, the cylinder has a diameter of 4, so that's 4 meters, so this is going to be 2 meters, its radius. And later we're going to have to find the height at which the cylinder goes up to. Okay, so first of all, we're going to find the volume here. The volume is length times width times height. Okay, but we need the same units. And notice our final answer, we want to find our final answer in millimeters. So it might be easier to change everything to millimeters right now. Alright, let me write that in red. So 6.5 meters, what to get millimeters, I multiply by 1,000. 6,500 millimeters, and this is going to be 10,000 millimeters. Okay, so then I can do my calculation. My answer is going to be in cubic millimeters. So volume equals 17.3 times 6,500 times 10,000. Okay, so I'm going to do that on the calculator. So 17.3 times 6,500 times 10,000. Okay, got that done. I get 11245 and then 5 zeros. So it's a pretty large number because it's in cubic millimeters. Okay, now over in this figure we have volume. The volume of this cylinder is pi r squared h, but again we want millimeters, so let me write that in millimeters. That radius is going to be 2,000 millimeters. Okay, so we're going to put that into the formula. So our volume is this huge number right here, which is 1,124,500,000. That's the volume. That should be equal to pi times the radius, which is 2,000 squared times the height. Okay, so the height is going to be equal to 1,124,500,000 divided by pi times 2,000 squared. Alright, so since the volume of this rectangular prism and the volume of this cylinder are equal, we can do that and solve for the height of the water in the cylinder. So I'm going to do that on my calculator. I've already got this number as the answer, so actually let me get the fraction here, and I can put in answer. That'll give me this number here. And the denominator, I just need pi times 2,000 squared. Okay, and we do that, and we get 89.5. Okay, we get 89.5 millimeters. Okay, this makes sense. If there's 17.3 millimeters of rain over this broad surface, it's gonna the height of the water in this cylinder is going to be a lot higher because it's a small surface there. Okay, next is the density formula. Density of an object is mass divided by volume. Find the density of a metal with mass 25 grams and volume 4 centimeters cubed. Okay, so that basically we just need to use the formula, D equals m divided by v, and we get D equals 25 grams divided by 4 cubic centimeters. So our density is going to be, let's use our calculator to calculate that first. 25 divided by 4 is 6.25. So we have 6.25 grams per cubic centimeter. Okay, next example, what volume is occupied by a lump of metal with this mass and this density? Well, again, we can use the formula. And we can plug in what numbers we have. We have 11.6 equals 3.62 divided by the volume. We don't know the volume. So we can here we can solve for v. Multiply both sides by v, and we get 11.6 v equals 3.62, and then we need to divide by 11.6. So we get v equals 3.62 divided by 11.6, and that's going to be, let's work that on the calculator, 3.62 divided by 11.6 gives us 0.312. So 0.312, and the volume is cubic centimeters. Okay, and the next example, the water supply department uses huge concrete pipes to drain stormwater away. What is the outside radius of the pipe? What is the inside radius? Find the volume of the concrete necessary to make the pipe. Okay, so the the outside radius, let's call it big R. The outside radius, what looks like it's going to be just 5 or 0.5 meters, right? So it looks like it's just going to be 0.5 meters. Let's keep it in meters. Alright, because half of this distance is 0.5. Now, if this is 0.05, then this distance is going to be 0.5 meters minus 0.05 meters. Okay, so that little r, that little radius, is going to be 0.45 meters. So we got the radii of both the small inside cylinder and the larger cylinder, the outside cylinder. And we need to find the volume of concrete necessary to make the pipe. So the pipe is this bit here, right? It's hollow on the inside, so we need to get the volume of the big cylinder minus the volume of the small cylinder. Okay, so I'm going to get volume large first. The large cylinder equals pi r squared times height, which equals pi times 0.5 squared times 2.5. And the volume of the small cylinder equals, well, again, pi r squared height, but the radius is different. It's going to be 0.45 squared times same height, which is 2.5. Okay, so I can get these two quantities and I can subtract them and I get the final answer, the volume of the concrete, I guess I could say. Okay. Alright, so let's find that with the calculator. I can literally just type out all that exactly, so I can do pi times 0.5 squared times 2.5, then minus pi times 0.45 squared times 2.5. Okay, and I do that and I get 0.714. 0.714 cubic meters of concrete is necessary.